Hey my dear data friends, it's Nicola from Data Mozart. End-to-end analytics solution. What's your first thought when you hear a term like that? Microsoft Fabric, right? But did you know that a few years ago Microsoft also introduced a solution that was branded and labeled as an end-to-end analytics solution? And it was not Microsoft Fabric. It's called Azure Synapse Analytics. So I think somewhere in 2020, Microsoft introduced Azure Synapse Analytics as an end-to-end analytics platform. So what happened in the meantime that Microsoft decided to go all the way with Microsoft Fabric? I discussed this topic in one of my previous videos, but today we are focusing on Azure Synapse Analytics, and I want you to introduce you to this solution provided by Microsoft. And the main difference between these two is that Azure Synapse Analytics is a platform as a service solution versus Microsoft Fabric, which represents software as a service solution. What's the main difference between platform as a service and software as a service? Let's start with that. Let's first explain what is a platform as a service. It's a solution where the provider of these services provides a software and hardware on their own infrastructure and then delivers this integrated platform as a solution to clients. So you write the code, you build and manage your applications, but you do it without the headaches of software updates, patches, hardware maintenance, and so on. So this is done by your provider. Whereas in software as a service, the entire application is managed by provider. So everything simply just works. And from that perspective, Microsoft represents software as a service solution, and Azure Synapse Analytics represent platform as a service solution. In this video, I want to introduce you to some of the essential concepts of Azure Synapse Analytics. In the next video or mini course, I'll introduce you all the advanced topics and features that you have to know when it comes to working with Azure Synapse Analytics. Enjoy! But before we dive deep in Azure Synapse Analytics, in order to put our discussion in the proper context, I'll spend a few minutes introducing the concept of the modern data platform, because in the end, that's what Synapse proclaims to be, a truly modern data platform. So let's first take a more tool-agnostic approach and learn about some of the key characteristics of the modern data estate. Please don't mind if I use some of the latest buzzwords related to this topic, but I promise to reduce their usage as much as possible. Okay, let's start with some history lessons and introduce a short history of data architectures. We'll kick it off with data warehouses. Data warehouses have a long history in decision support and business intelligence systems, being around for decades. They represent a mature and well-established architecture for handling huge amounts of structured data. And this is a typical workflow in a traditional enterprise data warehousing architecture. So we connect to the structured data stored in various source systems, let's say transactional databases, then we perform some transformations on this data to shape it in the form that is suitable for analytic workloads, doing things like aggregations and so on, before we load it into a central repository, which is an enterprise data warehouse. These enterprise data warehouses were, and still are, the focal point of the architecture, a single source of truth for all your organizational data. From there, we are using various business reporting tools, such as Crystal reports, yes, I'm that old, SQL Server reporting services, Power BI, of course if we are talking about Microsoft's reporting solutions, creating all kinds of different reports to support efficient business decision making. Specific group of people who are proficient in understanding and using SQL language could also connect and query the data directly from the data warehouse by leveraging other client tools such as SQL Server Management Studio or Azure Data Studio. However, times are changing. Not that I want to say that traditional data warehousing solutions are dead, on the contrary, but let's say that they needed to evolve to support new flavors of data. In the recent years, organizations acquire more and more data that's originating outside of the structured transactional databases. Things like social media data, images, videos, logs, information collected from IoT devices, and so on. which is hardly manageable using traditional data warehousing solutions. So we are talking about semi-structured and non-structured data. How do we handle these new flavors of data? We simply store them as it is in the data lake. Data lake can be used for storing all data types, structured, semi-structured, and non-structured. From there, again, we can perform our ETL operations to populate the enterprise data warehouse, and this part of the architecture looks exactly the same like in the previous case. However, it's not only about different data flavors, it's also about new roles in data space. Individuals like data scientists or machine learning engineers, people responsible for providing predictive analytics over all data types, not only those residing in the data warehouse. So these new kids on the block had to respond to business questions in a whole different way compared to what we used to know previously. Therefore, by giving them access over raw data stored in the data lake, we got a whole new architectural concept in place. Not only that, please pay attention to this arrow here. ETL process is not a one-way street anymore, meaning it's not populating only an enterprise data warehouse, but also a data lake itself. So essentially, we have two data storage locations here, a traditional enterprise data warehouse, but also organizational data lake. Things become a little complicated, right? Obviously, we needed, or at least some of the folks around thought that we needed, a more flexible and less complex solution. And that's when the latest concept was introduced. It's called Data Lakehouse. What else? I mean, if you combine warehouse and lake, what else you may expect than lakehouse, right? But why lakehouse? And what are the benefits of having a solution like this? Well, you may notice that this part at the bottom is exactly the same. We have our structured, semi-structured, and non-structured data, and we store it again in the data lake. However, instead of physically moving the data from the data lake to data warehouse, by introducing a metadata and governance layer directly on the data lake, plus performing all the ETL stuff within the lake itself, we are getting the best from both worlds. So what does this best from both worlds mean in real life? On one hand side, we have flexibility, cost efficiency, and scalability of the data lakes. On the other side, we can leverage features such as data management and ACID transactions that are at the core of traditional data warehousing architecture. The main benefit of this new hybrid architecture is that various data teams can perform faster without needing to access and consume the data from multiple systems. Additionally, by eliminating the need for physically moving the data, Data Lakehouse architecture enables that all the teams across the organization, data analysts, data scientists, and machine learning engineers, have the latest and most complete data available. However it sounds fancy and cool, you have to be aware of the specific prerequisites that enable rise of the data lakehouse concept. Metadata layers, for example an open source Delta Lake file format that supports transaction logging and ACID compliant transactions. This metadata layer also supports streaming I/O, time travel between the table versions, schema enforcement, and so on. Number 2 is performance. With enterprise data warehouses, you could have always rely on performance aspects because of their powerful engines and other features that enable performance optimization. When we are talking about data lakes, in the past it was really slow to access objects in the data lake. Now, with these new engines, such as Polaris engine in Synapse or Photon in Databricks, you can write SQL queries and quickly retrieve the data stored in the lake. Number 3 is accessibility for data scientists and machine learning engineers. Don't forget, folks in data scientist and machine learning engineer roles are usually super proficient with Python, Spark, and similar technologies, but they are not SQL gurus. So exposing the data from the data lake directly to them, while giving them a possibility to continue using their tools, is another strong argument for implementing a data lakehouse architecture. Can you recognize the object on your screen? Yes, that's the famous Swiss Army knife. You can cut the paper, open a bottle of wine or beer, or cut some smaller items. All of that using one single tool. So, if you're asking yourself, what on earth does the Swiss Army knife have in common with Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data needs. Do you need to import data from multiple different sources? Synapse can do that. Do you need to transform data before serving it? Synapse can do that too. Do you need to store the data? Synapse can do it for you. Do you need to query non-relational data or even files directly? Synapse can do that. Watch out now. Do you need to query non-relational data or even files directly using a plain old t-sql? Synapse can do that. What? Yes, you can write t-sql to query data from CSV, JSON or Parquet files, but more on that later in the course. Do you need to build machine learning models? Synapse can manage this for you. Finally, do you need to create your Power BI report straight from the Synapse? Yes, that is also possible. As you may notice, Synapse is a one-stop service for all your data tasks. Here is the quick 10,000 feet high overview of different components that make Synapse Analytics a Swiss Army knife for your data workloads. For SQL professionals, there are two pools in Synapse. The Dedicated SQL pool is the official successor of the former Azure SQL data warehouse. Then, there is also a Serverless SQL pool. Developers familiar with Python, Scala or Spark SQL can leverage the usage of the Apache Spark pool for processing large volumes of data. Last but not least, Data Explorer enables quick and efficient analysis of batch and streaming data. It's predominantly used for analyzing telemetry and log data. When it comes to storage, there are also a bunch of possible options to choose from. Starting with a traditional relational way of storing data in SQL Data Warehouse, then Spark Tables, Azure Data Lake Storage Gen 2 Data Lake, or all the way to non-relational document-style storage mode in Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. Finally, you can quickly visualize your data using, for example, Power BI. And watch out, here's the key takeaway. You have all these tools under one roof, either natively or as linked services, and you can build, manage, and deploy your end-to-end data analytics solutions from within a web-based user interface called Synapse Studio. The core part of this architecture is the analytic engines. There are 4 different engines within the Synapse workspace. 2 of them are SQL flavored, Dedicated SQL pool and Serverless SQL pool, while the third is based on Apache Spark technology, and that is Apache Spark pool. Also, 3 of them are provisioned, Dedicated SQL pool, Apache Spark pool and Data Explorer, which means that you need to provide some infrastructure in advance, while the 4th, Serverless SQL pool, works like a serverless solution. Let's kick it off by setting the stage for using Azure Synapse Analytics. In this demo, I'll show you how to create a Synapse workspace, the environment that you'll need when working with Azure Synapse. I'm in the Azure portal and I'm going to create a new resource. In the search bar on the top, I'll enter Synapse and then choose Azure Synapse Analytics service. Let's click on Create to kick off the process. The first prerequisite for creating a Synapse workspace is having an active Azure subscription. That's something you must have in order to use this service. I'll select my default subscription and under Resource Group, I'll select my existing Nicola E resource group. Of course, you can create a new one if you like. The next step is to define a workspace name. I'll call this one Mastering DP500, and since I'm based in Austria, I'll leave Germany West Central as region. The next very important prerequisite for using the Synapse workspace is Azure Data Lake Storage Gen 2. You must have ADLS Gen 2. You can use the existing one if you like, but here I'll show you how to create one from scratch. Let's give it the same name, Mastering DP500. And I'll set the same name for the file system. You can leave for now the default settings for the other tabs, such as security, networking and tags. And once you reach the final tab, which is Review plus Create, let's stop for a moment. Don't be afraid when you see the costs displayed on this screen. Provisioning a Synapse workspace per se will cost you nothing, but Microsoft warns you that you get a Serverless SQL pool provisioned by default, and once you start querying the data from the data lake using a Serverless SQL pool, you will be charged for the amount of data processed. Once I hover over this information icon, you may see that the Serverless SQL pool is a pay-per-query model, which we will discuss in more detail later in the course. So, to confirm once again, creating a Synapse workspace is free, but you will then be charged for using resources from that workspace. I'll now confirm my settings and wait for a few minutes for my workspace to be created. Here it is. Once the deployment is complete, I can go to my newly created workspace mastering DP500 and open it. This is the interface of the Synapse workspace. As you may see, under the SQL pools, we have our Serverless SQL pool type provided by default. From here, you can directly access the Synapse Studio, a web-based user interface for managing and monitoring your Synapse workloads. But more on Synapse Studio in one of the next videos. Let's first understand how the Serverless SQL pool fits within the data analytic workloads picture. Essentially, what a Serverless SQL pool could do for you is hardly beatable. You can query data directly within your data lake without the need to transfer or copy it anywhere. Moreover, you can query the data in the data lake writing plain old t-sql. Yes, CSV, JSON and Parquet files included. Since it is a serverless system, you don't need to set up any kind of infrastructure or clusters. You can literally start querying your data as soon as your workspace is created. The Serverless SQL pool works as a standalone poly-based service, so there are no costs for the resources reserved. You are only being charged for the volume of data processed by your queries. Just keep in mind, when you are planning your workloads, that the minimal billing volume is 10 megabytes. This minimal threshold doesn't apply to metadata queries, so you don't have to worry that you will be charged at all if you execute something like select star from sys.objects. Having this tool under your belt lets you think about an indefinite number of possible approaches. You can quickly perform ad hoc queries over data in the data lake before you decide what is the best possible way to gain more insights from it. You can build an additional logical layer, a kind of abstract data warehouse on top of raw or non-relational data without moving data to a physical storage. You can transform data directly in the data lake and consume it directly from there, for example using Power BI. As already mentioned, you can use t-sql to query the data directly from the data lake. And not just that, you can also write t-sql to retrieve data from Spark tables and Cosmos DB. Writing t-sql for querying non-SQL Server data is being achieved by using an extended version of the OpenRow set function. Before we dive deep into each file type, let's quickly describe which elements of the t-sql language are supported in the Serverless SQL pool. Full select surface area, including almost all SQL functions. Data definition language statements related to security and views, such as create and alter view. CTAS, which stands for create external table as select. You can think of it similar to something like select star into table in the traditional t-sql world. Obviously, there are certain t-sql operations that are still not supported in Serverless SQL. Since Serverless SQL doesn't support any data persistency, you can't create objects such as tables, materialized views, or triggers. Data manipulation language statements, for example insert, update, and delete, are also not supported. Before we proceed to examine all the pros and cons of CSV files, let me quickly introduce you to the concept of schema inference. Built-in schema inference enables you to quickly query the data in the data lake without knowing underlying schemas and data types. However, as every handy feature, This one also comes with a cost, and the cost is that inferred data types are sometimes much larger than the actual data types. For example, Parquet files don't contain metadata about maximum character column length, and inferred data type is always varchar 8000. Therefore, before doing serious things with Serverless SQL, I suggest you run the system store procedure sp describe first result set, which will return all the data types from the file. Based on the information obtained from running this store procedure, you may decide to adjust the data types for specific columns. One more important concept to grasp before proceeding further is called partition pruning or partition elimination. This concept means that the engine will be able to skip scanning those partitions of data that are not required by the query. Partition elimination may occur on two different levels. Vertical elimination happens on a column level, by skipping unnecessary columns during the query execution, while horizontal pruning assumes the elimination of the row groups that are not required by the query. Here is the list of the things you should do or not do when dealing with CSV files. Use parser version 2 when querying CSV files, as this will improve the query performance. Create statistics for CSV files. Statistics, same as in traditional relational databases, help the engine to come up with the optimal query plan. It's of particular importance for columns used in joins, where clause, order by and group by clauses. If you're dealing with huge files, it's a general recommended practice to split them into multiple smaller files. When we are talking specifically about CSV, try to keep the individual file size between 100 MB and 10 GB. When possible, convert CSV or JSON files to Parquet format. If you wonder why, just stay tuned and I'll explain very soon. Parquet is a columnar data format. Let's examine what that means. Each column in the Parquet file represents an individual unit and is physically separated from the other columns. Parquet also applies data compression techniques, so the memory footprint of the Parquet file is usually significantly smaller compared to the same data stored in a CSV file. Once again, make sure to handle inferred data types in a proper way. This is of paramount importance in Parquet file scenarios, because Parquet doesn't store the metadata about the maximum character column length. So if you don't explicitly handle data types, every character column infers the varchar 8000 size. The last file type I'd like to examine is Delta Lake format. You can think of it as Parquet on steroids. It's based on regular Parquet format, but in addition, it also provides a few important upgrades, namely support of the async transactions, which you may be familiar with from the traditional relational databases world. Delta Lake uses version Parquet files, which enables easy time traveling through the data stored in the data lake. Delta Lake also stores the transaction log to keep the track of all the changes made to the table or blob store directory. As we've already explained the importance of the partition elimination concept, let's wrap this section by listing some general recommendations for querying files stored in the Azure Data Lake storage. Leverage file name and file path functions to target specific partitions. In most real-life cases, data is stored in multiple partitions. Therefore, by using file name and file path functions, you can instruct Serverless SQL engine to target only those partitions that contain the data of interest. This will reduce not just the amount of data processed, but will also improve the overall query performance. Push filtering with wildcards to the lower levels. By using wildcards, you can query multiple files and folders. This means, whenever possible, push the wildcards filtering to the lower levels, as this will help the engine to skip scanning unnecessary files and folders. Optimize frequently ran queries by creating citas. Citas is one of the key features in Serverless SQL. By creating citas, you are essentially exporting the query results to another Parquet file. So, if you're frequently joining the data from multiple files, you should be better off materializing the result of these joins in the separate Parquet file, and then reusing that materialized result when needed. I'm in the Azure portal, And as you may see, I've already created a Synapse workspace. Let's open the workspace and get familiar with the main features here. Our focus will be first on this top part of the interface. There are multiple important properties here. For example, you can see endpoints for both dedicated and serverless SQL pools. This is useful whenever you want to access the data from these two pools by leveraging various client tools, such as SQL Server Management Studio or Azure Data Studio. You'll also find your Azure Data Lake storage account and SQL admin username as well. Down below, you will find all the analytics pools available. Remember, we've already learned that there are 4 analytics pools in Azure Synapse Analytics. As you may notice, at this moment I don't have any Apache Spark or Data Explorer pools provisioned, but under SQL pools there is a built-in pool, which is essentially a serverless SQL pool. Don't forget, a serverless SQL pool is provided out of the box as soon as you create a Synapse workspace. On the right hand side, you can see the size of the specific pool. In this case, size is set to auto, as the serverless SQL pool automatically scales to support your workloads, which is not the case for provisioned pools like Dedicated SQL or Apache Spark, where you have to define the size of the pool. Okay, that was a short intro to the user interface of the Synapse workspace. Let's now launch Synapse Studio, a web-based interface for managing, monitoring, developing and integrating data. Once I find myself in the Synapse Studio, under the Manage tab on the left, I will go to External Connections and then to Linked Services. Here, I can choose between a whole range of various services that can be leveraged as part of my Synapse workspace. On the top, you see the option to connect to Power BI, which is exactly what I need in this case. Let's first provide a meaningful name for our linked service, so I'll call it Power BI Demo DP500. Then, under the tenant, you can choose a tenant where your Power BI workspace resides. I'll use my Data Mozart tenant, and then I'll select the Power BI workspace that's going to be linked to my Synapse workspace. It will be a data workspace. I'll click on Create, and that's it! We've just integrated the Power BI workspace into our Azure Synapse Analytics workspace. That's nice, Nicola, but what should I do now? Fair question, so let's explore our options. First of all, if I go one step back to the home page of Synapse Studio, there is an option to visualize the data using Power BI. As you may notice, I can use any of the datasets from the linked workspace. So let's connect to Contoso DQ. Oh, this looks familiar, doesn't it? Of course, assuming that you've already worked with Power BI. So you can build a Power BI report directly from Synapse. Let me show you a very basic example. I'll drag the brand name column from the DIM product table. And let's put also the sales amount from our fact online sales table. There you go, the numbers are in. I can also play around and format this table a little bit, the same as I would do in Power BI Desktop, for example. I can also connect to the existing reports from the linked Power BI workspace. Let's quickly do that. I'll change the style of the table and click Save in the top right corner. If I move back to my Power BI workspace and open this report, ta-da! It's changed as per formatting style we defined in the Azure Synapse Studio. Finally, let's add another column to this table. For example, sales quantity. Save it again, and then navigate to the Power BI workspace. Yes, it's here! As you witnessed, Power BI and Azure Synapse Analytics can be seamlessly integrated to create impactful data stories directly from Synapse Studio web-based user interface. I'm again in Synapse Studio, but this time I'll leverage a Data tab on the left. Since I want to access the files stored in my Azure Data Lake, I'll go to Linked at the top and click on My Storage. Here, the data is organized into a folder structure. Let's open the data folder and check what's in there. As you may notice, there are multiple CSV files and one Parquet file. Essentially, both these files at the bottom contain exactly the same data, and that is the data about the yellow cab drives in New York City in January 2019. This is the open dataset, obviously containing not just data from January 2019, but also other years and months, so you can also download it and play around if you like. Why do I have exactly the same data stored twice? Well, the idea is to demonstrate the difference between the CSV and Parquet file formats, not only in terms of storage, but more from the querying perspective. You may spot that the Parquet file takes 105 megabytes, while the same data stored in the CSV file consumes 655 megabytes. Don't forget, Parquet is a columnar format and compresses the data in a more efficient way. Therefore, the memory footprint of Parquet files is usually way smaller than of CSV files containing the same data. Let's now explore the data. I can quickly get up and running directly from Synapse Studio. If I right-click on the CSV file and New SQL script, let's select top 100 rows to see how the data looks. Wow, Synapse generated the code for me, so I can instantly see the contents of the CSV file. Wait, why are these column names so weird? C1, C2, C3. Looks like my real column names are in the first row. So let's fix this quickly. I'll add another parameter to the openRowSet function. Header underscore row equals true. And now I see my column names displayed correctly. Two things to keep in mind here. Querying files in Synapse Serverless SQL pool is enabled by using the openRowSet function. This is the key ingredient for this query to work. The other thing is CSV related. Always use parser version 2, as this will provide a better query performance for CSV files. Okay, let's apply the same for the Parquet file. This time column names look good, so nothing to change here. Now let's move on outside of the Synapse Studio. Remember when I told you that you can use a Serverless SQL endpoint to connect and query the data from other client tools, such as SQL Server Management Studio or Azure Data Studio. In this case, I'll use SQL Server Management Studio. Let's simply paste the same query we've just executed in Synapse Studio. As you may see, the results are the same. Before I show you the difference in the query cost between the CSV and Parquet files, let me briefly explain how to handle the automatic schema inference feature. If you recall, we've learned that schema inference is the feature that enables you to quickly get up and running with your serverless SQL queries, without having an idea about the underlying schema and data types. However, this handy feature comes with a cost, and the cost is that inferred data types can be larger than needed. Let's run the system stored procedure sp describe first result set, and as a procedure parameter, I'll pass the query that we want to examine. Since Parquet doesn't store the metadata for maximum character column length, as you may observe, all text columns are of data type varchar 8000, which is far from optimal. So it's a recommended practice to handle inferred data types in a proper way, and this store procedure may give you a good starting point for the optimization process. The next thing I want to show you is setting limits for the amount of data processed. Don't forget, Microsoft will charge you for the amount of data processed, so if you don't want to end up paying too much, you can set the limits on a daily, weekly and monthly basis. I'll first check the current limits by running this query. It's 1 terabyte per day, 2 terabytes per week and 10 terabytes per month. Now, if I want to change, let's say, the monthly limit, I can run this sp set data processed limit store procedure and set the limit to 5 terabytes. Let's confirm that we changed the monthly limit. Yes, that was super easy. Finally, you may also want to check the current amount of data processed by running this query. I've also enhanced this query by including the current price per terabyte, which is $5, so you can quickly check how much money Microsoft will ask you to show them for querying the Serverless SQL pool. Fine, now I want to show you how you can combine the data from multiple different data sources without exposing the underlying logic to the end user. Here is the query. First, I have a database view that combines the data from the CSV and Parquet file, so data from both files are in the single database view. Then I'm joining this view with another view that retrieves the data about the public holidays in the USA, stored in a different Parquet file. Essentially, we have one single query that looks like a regular t-sql query from SQL Server, whereas under the hood, the data comes from 3 different files and 2 different file formats. Theoretically, I could have also used the view created over the data from the Cosmos DB and included it as a part of this query. One last thing, but maybe this one is the most important from this demo. I want to show you the difference in query cost between the CSV and Parquet files. The scenario is as follows. I have CSV and Parquet files containing the same data, yellow cap drives from January 2019. I'll run 2 different queries on each of the files. The first will retrieve all the columns from the file, meaning we'll run select star, while the other will return only 3 specific columns. The reason for doing this is to check if the vertical partitioning is happening and if the engine is capable of skipping the scanning of unnecessary columns. Let's start with all columns from Parquet file. You can see that the total size of scanned data is 186 megabytes, while the size of moved data is 720 megabytes. Obviously, we have 0 for written data as we haven't exported query results anywhere. The next run goes for 3 specific columns from the Parquet file. This time, the amount of scanned and moved data is significantly lower, 79 and 146 megabytes respectively, which means that the engine was able to skip the scanning of the columns that are not part of the query. It's time to run the same query over a CSV file. The amount of data scanned is 688 megabytes, while we also have 62 megabytes for moved data. One last scenario to check is retrieving all the columns from the CSV file. Again, we have 688 megabytes of scanned data and 668 megabytes of moved data. This means if you're dealing with CSV files, it doesn't matter if you retrieve the data from just a few columns or all the columns. There is no vertical partitioning and the engine will scan all the columns in each and every scenario. Therefore, whenever possible, try to convert CSV files to Parquet or Delta format, as this should improve the performance and reduce the query costs. To wrap up this demo, please pay attention to the predicates in the where clause. Here, I'm leveraging a file path function to scan only the file needed by the query. File path function returns a full or partial file path. In this example, you can see how I've swapped asterisk symbols with explicit values, thus instructing the engine to look only for the data for January 2019. Unlike dedicated SQL pools, serverless SQL pools contain only metadata, not the real data itself. However, serverless SQL still offers the possibility to establish a certain structure over your data coming from Azure Storage, Azure Data Lake, Cosmos DB, or Microsoft Dataverse. This structure may be implemented using views or external tables. The main difference between the two is that you can use external tables not just to read data, but also for writing the data by using citas. Creating external tables in a serverless SQL pool consists of 3 separate steps. Creating an external data source as a reference to an external Azure storage account, including the credential that's going to be used for accessing the storage. Creating an external file format to describe the file format of CSV or Parquet files. Creating an external table on top of the files located in the specified external data source and using the format defined in the external file format. It's not that you're limited to writing basic and simple t-sql queries when you are querying the data from a serverless SQL pool. The majority of t-sql language features are also supported in serverless SQL scenarios. In this demo, I'll show you a few examples of more advanced queries. Here, I'm using a sum aggregated function to summarize the amount per vendor and date. Next, I can also apply some data transformation by leveraging t-sql capabilities. In this case, I'm using a pivot transformation to traverse rows into columns and put all my vendors into the columns. Finally, let's understand how to create external objects in the Serverless SQL pool. The first step is to create an external data source. I already have some, so let me quickly show you how it's done. This one is my Azure Data Lake storage, the one I already showed you in Synapse Studio. So I'm simply providing the location of this external data source. The other one points to the Azure Open Data Storage, specifically to a folder that contains the data about yellow cab drives in New York City. The next step is to create external file formats. Again, I've already created two of them. Let's first check CSV with headers. Most of these parameters within the brackets are optional. The only mandatory parameter is format type, which is a delimited text in this case. For Parquet external file format, I just specified a format type, but you can also extend this with additional optional parameters. The final step is to create an external table. If you go to Tables and right-click on External Tables, you can create a new external table. You should simply replace the required parameters in this automatically generated script with the values created in the previous steps. We are talking about location, data source and file format, and you are good to go. Unlike with the Serverless SQL pool, where you don't need to provision any Azure resources, when using a dedicated SQL pool, you must set up the infrastructure in advance. Even though a dedicated SQL pool is mostly used for relational data workloads, and you may think of it as a SQL server on steroids, the underlying architecture is quite different, as a dedicated SQL pool reaps the benefits of using massively parallel processing architecture. This architecture supports efficient processing of large amounts of data, as the query can be split into multiple smaller chunks, and each chunk is set to one of the compute nodes that work in parallel to process the query as a whole. Let's now focus on explaining how the tables are physically implemented within the Azure Synapse Analytics dedicated SQL pool. When it comes to data persistency, there are three main table types. Regular table, which stores the data in Azure storage as part of a dedicated SQL pool. Data is persisted in the storage regardless if the session is open or not. Temporary table uses local storage to store the data temporarily, only while the session is open. The main reason for using temporary tables is to prevent users outside of the session to see the temporary results, but also to speed up the development process by storing the intermediate results in local instead of remote storage. External table, similar to one that we examined in the previous module, points to the data stored in Azure Data Lake or blob storage. External tables may come in handy when loading the data into the dedicated SQL pool. Partitioning concept is also relevant for the dedicated SQL pool. The most common scenario is to partition the data on the date column. Obviously, depending on the amount of data, you may decide to partition on year, month, or day level. The overall query performance can be significantly improved by applying an appropriate partitioning strategy. However, be mindful when creating partitions, as sometimes too many partitions can downgrade the query performance. There is no single golden number of partitions that you should create. Essentially, it depends on your data and the number of partitions that need to be loaded in parallel. Although there is no single golden number of partitions for the table, in reality we are usually talking about tens or hundreds of partitions, but definitely not thousands. If you are partitioning the data in clustered column store table, you should think about the number of rows that will go in each partition. To get the optimal compression rate, every distribution and partition should contain at least 1 million rows. Also, keep in mind that the dedicated SQL pool's architecture is based on massively parallel processing, which means that even before you create your partitions, each table is already split into 60 distributions. Table partitioning can also bring multiple benefits to the data loading process. The final thing to be aware of regarding partitioning is that you can apply partitioning only on one column.
That's all, folks. If you like this video, make sure to click this like button down below. Also, if you want to stay up to date with all the latest information about Microsoft data platform world, namely Power BI, Microsoft Fabric, and of course Azure Synapse Analytics, make sure to click this subscribe button. See you soon!